Class 9. Subject Science Physics. Chapter 8. Force and Laws of Motion. Topic to be learned in this video. Third law of motion. Newton's first law of motion from second law. First law states that if external force, F, is equal to 0, then a moving body keeps moving with the same velocity, or a body at rest continues to be at rest. We know F is equal to m into a, or F is equal to m into v minus u divided by t, or F t is equal to m v minus m u. That is when F is equal to 0 and v is equal to u for whatever the time t is taken. This means that the object will continue moving with uniform velocity u throughout the time t. If u is 0, then v will also be 0. That is, the object will remain at rest. Example 1. A constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. Now, if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? Solution. We have been given that initial velocity, u, is equal to 3 meter per second, and final velocity, v, is equal to 7 meter per second. Time t is equal to 2 seconds, and mass, m, is equal to 5 kg. From equation we have force F is equal to m into v minus u divided by t. Substitution of values in this relation gives F is equal to 7 minus 3 multiplied by 5 and divided by 2 is equal to 10 Newton. Now, if this force is applied for duration of 5 seconds, then the final velocity can be calculated by rewriting equation as v is equal to u plus f t divided by m. On substituting the values of u, f, m and t, we get the final velocity v is equal to 3 plus 10 into 5 divided by 5 is equal to 13 meter per second. Example 2. A motor car is moving with a velocity of 108 km per hour and it takes 4 seconds to stop after the brakes are applied. Calculate the force exerted by the brakes on the motor car if its mass along with the passengers is 1000 kg. Solution. The initial velocity of the motor car, u, is equal to 108 km per hour. Kilometer per hour changes into meter per second is equal to 30 meter per second, and the final velocity of the v is equal to 0 meter per second. The total mass of the motor car along with its passengers is equal to 1000 kg and the time taken to stop the motor car, t, is equal to 4 seconds. We have the magnitude force, F, applied by the brakes as m into v minus u divided by t. On substituting the values, we get F is equal to 1000 into 0 minus 30 divided by 4 second is equal to minus 7500 kg meter per second square, or minus 7500 Newton. The negative sign tells us that the force exerted by the brakes is opposite to the direction of motion of the motor car. Third law of motion. The first two laws of motion tell us how an applied force changes the motion and provide us with a method of determining the force. The third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. These two forces are always equal in magnitude but opposite in direction. These forces act on different objects and never on the same object. Let us consider two spring balances, connected together as shown in figure. The fixed end of balance B is attached with a rigid support, like a wall. When a force is applied through the free end of spring balance A, it is observed that both the spring balances show the same readings on their scales. It means that the force exerted by spring balance A on balance B is equal but opposite in direction to the force exerted by the balance B on balance A. Any of these two forces can be called as action and the other as reaction. This gives us an alternative statement of the third law of motion, that is, to every action there is equal and opposite reaction. It must be remembered that the action and reaction always act on two different objects simultaneously. The action and reaction forces are always equal in magnitude. These forces may not produce accelerations of equal magnitudes. This is because each force acts on a different object that may have a different mass. It is important to note that even though the action and reaction forces are always equal in magnitude, these forces may not produce accelerations of equal magnitudes. This is because each force acts on a different object that may have a different mass. When a gun is fired, it exerts a forward force on the bullet. The bullet exerts an equal and opposite force on the gun. This results in the recoil of the gun figure. Since the gun has a much greater mass than the bullet, the acceleration of the gun is much less than the acceleration of the bullet. Thanks for watching. Please like and subscribe my channel.